Hello everyone, welcome to my civil engineering YouTube channel. Please subscribe to it and hit the bell icon to get notified when I post my new videos. Today, I'll be discussing regarding a numerical on three-hinged parabolic arch with supports at different levels. So, I have shown in a sketch there is a three-hinged parabolic arch with two hinged supports, that is A and B. C is the crown point. So it is having a rise, two risers levels are observed here. One is of 3 meters height from A to crown point C, and another distance of the rise is 6.75 meters, which is from the support B to C. The total span of the arch is given as 22.5 meters, and the arch carries a UDL, that is a uniformly distributed load of 30 kilonewton per meter from A support A to that of the crown. So they have asked to determine the positive and negative bending moments. So here it has been observed that L is the total span distance, and in the sketch they have given the height of the different heights of the riser from the support condition, from the respective supports, but they haven't given what is the value of L1 and L2, yeah, wherein L1 and L2 are the different length between the support A to C, and between L2 is between the support B to the crown point C, that is a midpoint. Okay, so here the first and foremost step is that we in order to determine what is a positive and negative bending moment, first we are supposed to find out what are the different spans between the supports to that of the crown points, right? So first step is to determine the values of L1 and L2. Here we have, since it is given as a parabolic arch here, so we have the property of parabola as L1 square by H1 is equal to L2 square by H2. So I repeat it, L1 square by H1 is equal to L2 square by H2, wherein here L1 is the span between support A to crown point C, and L2 is the span between the support B to the crown point C. H1 is the height of the rise between A to C, the vertical distance between A to C, and H2 is the height of the rise, that is the height between the vertical height between the support B to C. So here L1 L L is equal to L is equal to L1 plus L2, L1 plus L2 into root under H1, root under H1 divided by root H1 plus root H2. This is a formula which is by the property of parabola it has been derived. So L1 is equal to L1 plus L2, that is nothing but the total value of L1 plus L2, we can take it as L itself. So it can be straight away set as L1 is equal to L into root H1 divided by root H1 plus root H2. I repeat it, L1 is equal to L into root H1 divided by root H1 plus root H2. So we know what is the value of L, that is a total span length, total span distance, that is 22.5 meters. So H1 is 3 meters, so H2 is 6.75 meters here. So the equation becomes L1 is equal to 22.5 into root 3 divided by root of 3 plus root 6.75. Therefore, the value by solving this equation, we'll get the value of L1 as 9 meters. So again, we know that L1 plus L2 combinedly will get the value as L. So L and L1 is known. By this we can just find out what is the value of L2, that is 22.5 is the value of L minus that of L1, that is 9 meters. So you will get 22.5 minus 9, you will get the distance, total distance as 13.5 meters. That is the span length between the support B to that of the crown. So the coming on to the next step, that is applying the equilibrium conditions in order to determine the support reactions. So I just apply the vertical equilibrium conditions for the arch. So we have the two vertical forces here, VA, VB. For the supports we have two vertical forces, that is a vertical reaction, that is VA and VB, which are in the upward direction. So upward forces are taken as positive and downward direction forces are taken as negative as per the sign convention. So here, so VA plus VB is equal to, so 30 kilonewton per meter is the load given, that is a UDL, which is acting to the span of L1. So L1 we have determined the value as 9 meters. So 13.7 kilonewton per meter, we need to convert that into kilonewton first. So multiplied by the total distance to which the load is acting. So 9 meters is the total distance to which the load is acting. Therefore VA plus VB will be equal to 30 into 9, that will be equal to 270. Since the 30 into 9 is in downward direction, therefore I have equated upward forces is equal to that of the downward force in order to obey the equilibrium condition. So the next step is moment about left support, moment about the crown. So I have to take the moment about crown. So in order to consider the moment about crown, in order to determine the value of H, we have H is another unknown here. So in order to determine the value of H, that is a horizontal reaction, I need to take the moment about crown. So first I am going to take the moment about crown from the left side support. So however, when we take the moment about the crown point, the total moment about the crown point will be always equal to 0 itself. So I repeat it. So when we take the moment about the crown point, always you will be having the total moment about that point will be equal to 0 itself. Therefore, if I take the moment about the point, so I need to equate that moment is equal to 0 itself. Okay. So next, I just take the moment from the left side of the support first about point C. Therefore, I have the forces such as VA, H and 30 kilonewton per meter. So again, I also consider the sign convention for the moment as clockwise moments as positive and anti-clockwise moments as negative. So VA into L1 minus H into VA into L1 is in clockwise direction, hence I have considered it as positive. So H into the H1. So H1 here is nothing but the rise distance between the support A to C. So it is in anti-clockwise direction, hence I have taken it as negative. So H into H1 and then 30 you have the remaining force. So 30, first that 30 kilonewton per meter, I need to convert that 30 kilonewton per meter to that of the point load. So that is in terms of kilonewton. So multiply that to the distance throughout the UDL is acting. So 30 kilonewton per meter into 9 meters. And then, as I said, that the moment for UDL it will be maximum in the centroidal location. So the centroidal distance will be half of the span here. So into 9 by 2 will be equal to 4.5. I repeat it once again. So when I take the moment about C point from the left side of the support, from the sign convention I have stated that clockwise movements are considered to be positive and anti-clockwise movements are considered to be negative. So I have three forces here in the left side of the crown. So that is VA, H, and then 30 kilonewton per meter. So VA into L1, VA into L1 is in clockwise direction, and then H into H1. H1 is the rise distance between A to C, that is 3 meters, and then the remaining force is 30 kilonewton per meter. So it is acting in downward direction first, the 30 kilonewton per meter. Convert that 30 kilonewton per meter into the kilonewton by multiplying to the load distance to which it is acting into the half span of load to which it is acting. Equate that to 0 since VA L1 is known and H1 is also known. So you just make that into a simplified format. So it will be equal to VA will be equal to, I just brought down this equation to a simplified format as 0.33H plus 135. So VA will be equal to 0.33H plus 135. Since H is unknown, so I just keep it as it is. Now, in order to determine, since it is a different level of a support condition here, so again I have to take the moment about C point from the right side of the support here. Since it is a different level of the support, I need to consider the moment of to the crown from both the support, and I need to equate that to 0 in order to get the value of the horizontal reaction. Therefore, I need to consider the moment from right side of the support about point C. Therefore, the forces acting at the right side of the support are VB and H itself. Only two forces are acting, that is vertical reaction at B and the horizontal reaction H. Therefore, VB, and again the sign convention here is clockwise is positive and anti-clockwise moments are taken as negative. So VB into L2, VB into L2, it is in anti-clockwise direction, VB into L2, and then H into H into H, H into H2, H into H2. So if I just solve this, I'll get the equation as, if I just solve this, I'll get the equation as VB is equal to 0.5 H. VB is equal to 0.5 H. So, and from considering the equation 1, I have got VA plus VB as 270 kilonewton. So if I just substitute the values in terms of H, that is VA I have got as a 0.33 H plus 135, and VB I got it as a 0.5 H. So substitute the values in terms of H in equation 1. So I'll get the thing as by solving that equation I'll get the value of H as 162 kilonewton. So again, so after finding the value of H, so if I just substitute the values in the equations, I'll get VA as 189 kilonewton and VB as 81 kilonewton. So by this I have found out what are the different support reactions. So the next step is I need to determine what is the maximum positive bending moment and the negative bending moment. So the first and foremost thing is to determine the maximum positive bending moment. For that, I always suggest that whenever there is a unsymmetrical loading, So in the sketch, I can just observe that in the left part of the support, that is in the A side, the support A side, only you have the loading, the external loading. It is only subjected to the external loading in the left part of the support. But whereas in case of right side of the support, there is no external loading, it is observed there. Or only you have the support reactions. So by seeing that sketch, you can just directly guess that where will be the position of the maximum positive or negative bending moment. So whenever there is a loading, so in that part you can just suggest that there will be the consideration of the maximum positive bending moment. So with that assumption, I have taken the left part of the arch. So I have considered the section xx, which is at the distance of x from the support A, and which is having the vertical distance. So this is the vertical distance y, that is the distance between the arch rib to that of the support level. So that is nothing but y distance, the vertical distance between the arch rib to that of the support level. So I have also considered the section xx, which is at the distance of x from that of support A, and L1 is the span distance between the support A to that of the crown. Okay, so I'm just considering the section xx, and then I'm also considering the moment xx, moment about section xx. So in order to determine the positive bending moment, I'm going to consider the moment about xx. So if I want to consider the moment about xx, so here I can see the three forces here. That is, one is Va, another one is H, and one more is 30 kilonewton per meter, which is acting at the distance of x here. It is not the distance of L1, it is a distance of x, because I am going to consider the moment about the section xx. So the moment about the section xx will be equal to Va into x minus h into the vertical distance. This is a vertical distance, that is y. So since it is in the anti-clockwise direction, hence I have taken it as a negative. So it is Va into x minus h into y, and then the remaining force is 30 kilonewton per meter. First you need to convert the 30 kilonewton per meter to the kilonewton. So since it is acting at the distance of x here, so 30 into x into the half the span, that is 30 into x by 2. So this will be the equation for mxx. Now I have derived in my previous lecture series the expression for rib distance in case of parabolic arch. So that will be equal to y is equal to 4hx into L minus x divided by L square. That is for the supports at same level. But here you have the support condition at different level, and I also have considered the half the span here. I have considered only half span of the arch here. The rest of the span, that is the L2 distance, I have not considered here. So this formula, that is y is equal to 4hx into L minus x divided by L square, will become 4hx into L will become here as 2 times that of L1. I repeat this, in case of the arches at different levels, L will become 2L1. Why it is L1? Because I am considering the left side of the span, where the span distance here is L1. Therefore L will become 2 times of L1, and then similarly L square will become 2L1 square. Therefore solving that, I'll get an equation as y is equal to 4 into 3 is the 3 is the h, that is the riser, that is a riser, into x is the unknown x value, the unknown distance, into 18 minus, why it is 18? Because 2 times of L1, yeah, 2 times of L1 is 9, so 9 into 2 it will be 18, minus x into 2 times of L1 square. So here I have got the simplified version of, after substituting all the terms in mxx equation, I have got the simplified version of mxx as 81x minus 9x square. 81x minus 9x square. So this is the general expression for the value of moment about xx section. So I want what is the maximum value of the moment. So in order to find out the maximum value of moment, I can just generally straight away say that wherever the moment is maximum, the shear force should be definitely equal to 0. So I can get the equation of shear force from this general expression of the moment by differentiating this expression of moment with reference to x. So if I just differentiate this mxx with reference to x and equating that to 0, I will get what is the value of the x. What is the value of x? So that is nothing but the distance at which, distance from the support A at which the moment is maximum. So I'll get it as 81 minus 18x is equal to 0. So x is nothing but 4.5 meters. For the distance of A, for the distance of x as 4.5 meters from A, I will get the maximum positive bending moment. Okay, so this is the value of x. So if I just substitute the value of x in the simplified format of mxx equation, I'll get what is the value of the maximum bending moment. So that is nothing but 81 times of 4.5 minus 9 into 4.5 x square. If I do it, I'll get what is the maximum value of the bending moment, positive bending moment, that is 182.25 kilonewton meter. So this is how to determine the maximum positive bending moment. So the next step is the determination of maximum negative bending moment. So while determining the maximum positive bending moment, we have considered the left span. Why? Because in the left side of the span, there was the load acting. So obviously in the right side of the span there is no there is no action of the external load. Therefore you can just directly say that it will be subjected to the negative bending moment. So with this assumption, I am just considering the right side of the span. For this right side of the span, I am going to consider again the section xx, which is at the distance of x from the support B, and then L2 is the span length from B to the crown point, and H here is the riser, which is having the distance of 6.75 meters. So here y is nothing but the distance, the vertical distance between the arch rib to the top of the support level. So again I need to find out what is the value of moment at the section xx. So only two forces I have here. One is VB and one more is H here. So VB into X, VB into X minus H into Y. So again here in I need to put the parabolic expression, the general parabolic expression. Y is equal to 4hx into L minus x divided by L square. Here in case of the right side of the support here, L will be equal to L2. Therefore, since it is a different support condition, so it is L will become 2L. So here with reference to L, L will be equal to L2. Therefore, it is equal to 2L2 minus x divided by 2L2 square. Okay. So here if I just substitute the values there, y, I'll get the what is the value of y, and similarly the substitute the value of y in case of the moment equation. So I'll get the simplified form of the moment equation as minus 81x plus 6. Similarly, if I want to find out the maximum negative bending moment, whether it is positive or negative in nature, the if I just say the word as maximum bending moment, therefore then there will be the shear force, the tangential force will be zero there, or therefore in order to have the shear force as zero, I need to differentiate again with reference to x for the general expression of the moment here and equate that to 0. So if I just do that, I'll get what is the value of x, that is 6.75 meters I have got. So if I just substitute that value of 6.75 to this general expression of the moment, I'll get what is the value of the negative bending moment. So that is 273.38 kilonewton meter. So these are the values of positive and negative bending moment. So maximum positive bending moment I have got as 182.25 kilonewton meter, and negative bending moment I have got as 273.38 kilonewton meter. Thank you.